Hello everyone. So we are going to start a new topic, the pharmaceutical engineering. This is the evaporation. Now, this whole topic it has been divided into different parts, which comprises different aspects of the topic evaporation. So in the part one, we are going to deal with the different definition of the process of evaporation, their application in the pharmaceutical engineering, as well as factors which actually determine the process of evaporation. So without wasting any time, let's start. So in the basic introduction, if somebody asks you the definition of evaporation, so simply evaporation, it is a very simple process. So it's a type of phase transition. Phase transition means it is the process by which the molecules in the liquid state generally, I repeat, the molecules in the liquid state, in case of water, they get spontaneously converted into the gaseous form, that is the water vapor, right? So, and the equipment which are used for the process of evaporation, these are known as the evaporators, which are used in the pharmaceutical industry. Now, the purpose of evaporation. Why we choose the evaporation? First of all, to concentrate the solution by removing the vapor from a boiling liquid. I would like to elaborate this line, to concentrate the solution. So suppose we have taken a glass of water, right? Now, in this glass of water, suppose we have added 1 teaspoonful of sugar, right? And we have stirred this sugar in the water. So when you taste this water, it will taste quite sweet, but not sweeter. Now if we concentrate this sucrose or sugar solution by evaporating the water present in there, we can simply do it in our household activities, just like warming of the water in a pan, right? What will happen? Once it will get concentrated, the sweetness of that liquid will become more, right? So similarly for pharmaceutical dosage preparation, we prefer to concentrate the solution. I repeat, we prefer to concentrate the solution by the process of evaporation, right? The next thing is that in majority of the cases, the evaporation it refers to the removal of water from an aqueous solution. So whenever we use the term evaporation, it simply refers to the removal of water from an aqueous solution. Aqueous solution means any solution that has been made by using the water. For example, the concentration of aqueous solution of sugar, as I already told you, sodium chloride, it is a common table salt, right? Sodium hydroxide, glycerol, glue, milk, orange juices, etc. Right? So in these cases, actually the concentrated solution is the desired product, right? Means sometime when we need a product which is more sweeter, in such cases what we will do? We will simply heat off, or we will simply evaporate the less sweeter solution to make it a more sweeter solution by concentrating it, right? So the concept of evaporation and distillation. So how do these processes they differ from each other? See, simply I have given an example. So in the evaporation process, actually the vaporization takes place below the boiling point. The vaporization takes place below the boiling point. Means in the case of evaporation, the water it don't boil, it don't get boiled before reaching the boiling point. Once it will reach the boiling point, it will start boiling, right? Bubbles will come out, right? So before reaching the boiling point, the vapors which escape from this aqueous solution, they are removed, right? But in case of distillation, the vaporization it takes place in the boiling point. Here the boiling point need to be reached, right? Next, the evaporation it takes place during, you can say evaporation takes place only from the surface of the liquid, as because in the process of evaporation we never allow boiling. That's why from the surface of the liquid only the vapor will escape or the water will escape. But in distillation, it will take place from the whole liquid mass, because the liquid is now boiling, bubbles are forming, so whole liquid mass it is available for the process of removal of water. For evaporation, it takes place below the boiling point, right? As we have already stated. So there is no bubble formation in the evaporation, but in the distillation process, the bubbles will form. Moreover, the evaporation, it is not necessarily a separation technique or a purifying technique, because it always takes place at the surface. But whereas the distillation, it is a separation technique, because we used to distill different plant extract. Moreover, it's a purifying technique. We get the distilled water, right? So evaporation, lastly, it is a slow process, whereas distillation, it happens very fast, right? Now, the difference between evaporation and drying. So most of you might sometimes get confused between the evaporation and drying. So basically, the term drying, it usually refers to the removal. I repeat, the term drying. Drying means removal of relatively small amounts of the water from the solid or nearly solid material like paste, right? Whereas evaporation is usually limited to the removal of large amount. In the drying, less amount of the water is removed, but in evaporation, large amount of the water is removed from the solution, right? So in most cases, the drying involves the removal of water at a temperature below its boiling point. I repeat, in the drying, it involves the removal of water at a temperature below its boiling point. Whereas evaporation means removal of water by boiling a solution. I repeat, in most cases, don't get confused, in most cases, the drying involves removal of water at a temperature below its boiling point, right? Whereas evaporation means the removal of water by boiling a solution. Now, application of evaporation process in the pharmaceutical operation. First of all, in the manufacturing of bulk drugs, different API, they are prepared by the process of evaporation. Evaporation process, it is generally used to make concentrate, right? Next, manufacturing of biological products like vaccine, serums, interferons, these are generally concentrated by using the process of evaporation. Next, we have manufacturing of food products. So different food products like your juices, lemonade, whatever it is, they are concentrated, but they are generally manufactured by using the process of evaporation. Next, manufacturing of demineralized water. It's a very essential component in the formulation of different parenteral drug. So manufacturing of demineralized water, it also exploits the process of evaporation. Next, minimize the chances of chemical reaction. Whenever you get any chances of chemical reaction, that some sort of chemical reaction may take place, suppose hydroxylation, right? In such cases, you need to remove the water. In such cases, we always prefer to use the process of evaporation, right? Next, prepare the product for next operation like drying. So before drying, whenever we mix the additives to make the tablet, capsule, whatever it is, we always need to remove the water, and this removal of water, it is done by simple evaporation method. Next, to improve the product storage life. We all know that water, if it is present in any product, this product can lead to microbial contamination, because the microbes, they need the water to get nourished, right? So if we remove the water, the life of the product, it will be extended. Means whenever you want to improve the life, means earlier suppose water is present, then the product can be stored for a period of 1 month. But if you remove the water from that product, then the product might be stored for 1 year. Next, similar to that, decrease the impact of microbial growth. So upon removing the water by the process of evaporation, the microbial growth can be controlled, and this will finally improve the storage life or shelf life of the product. Now the thing is that what are the factors which affect the rate of evaporation? So basically there are 7 factors which affect the rate of evaporation. These factors are temperature, the surface area, the agitation method, the atmospheric, aqueous, vapor pressure. We will discuss this. Next, the atmospheric pressure on the liquid under the evaporation, type of the product which is required, and economic factors. So all these factors will be discussed in the next slide. So the first factor, it is the temperature. The rate of evaporation, it is directly proportional to the temperature. So if we keep on increasing the temperature, the rate of evaporation will be increased. But I repeatedly I am telling you, but this temperature should be lesser as compared to that of the boiling point. It should not reach the boiling point. If it has reached the boiling point, then distillation will take place. Right? Next, surface area. The rate of evaporation, it is directly proportional to the surface area. The more is the surface area, the more will be the rate of evaporation. So simply, if we take suppose a specified quantity of water in a glass, and similar quantity of water is taken in a plate. If the surface area of the plate is more, the rate of evaporation from the plate will be more. So the rate of evaporation is directly proportional to the surface area of the vessel. Right? The next one, it is the agitation. So agitation, it is always needed for evaporation. So what is agitation? Agitation is nothing but it's a simple mechanical shaking or movement of the liquid. So agitation, it is always needed. If agitation is there, then the rate of evaporation will be more. The next thing, it is the atmospheric aqueous vapor pressure. So what is atmospheric aqueous vapor pressure? It is simply nothing but the humidity, the amount of the water vapor which is present in the atmosphere, right? So if the area where you are taking or where you are conducting the evaporation process, if in that area the atmospheric aqueous vapor pressure is more, in that area the rate of evaporation will be less. Thus, the rate of evaporation is inversely proportional to the atmospheric aqueous vapor pressure. Right? Next, we have the atmospheric pressure on the liquid under the evaporation. So, the rate of evaporation of any liquid, it is inversely proportional to the atmospheric pressure on the liquid under the evaporation. If the atmospheric pressure is more on the liquid which we are evaporating, if the atmospheric pressure is more, then what will happen? The rate of evaporation will be less. And if the atmospheric pressure is less, then the rate of evaporation will be more. That's because due to less pressure, more amount of the water or vapor can escape from the liquid, right? The next one, it is the type of the product required. So the selection of the method of evaporation, what method we are going to select, right? And the apparatus, what apparatus you are going to select for the evaporation, it depends upon the type of the product you require. For parental product, you are going to use different type of evaporation method. For general ophthalmic product, you are going to use different type of evaporation. For general liquid production, you are going to use different type of apparatus, different type of method. For generally concentrating any drug molecule or any formulation, you will have different type of method, right? And lastly, that is the economic factor. So while performing all this, we need to also see the economic factors. So when selecting any method and the apparatus, the economic factors are very important. We always need to see in which process the amount of the cost it is less, so that the process can be eventually takes place. So that's all from the first part. So thank you everyone for your patience hearing. If you like the video, just press the like icon. You can share this video with your classmates and colleagues. And for further notification from this channel, you can subscribe my channel. Thank you once again.